Okay, let's look at your Module 3 test review. So this first couple questions all deals with this first function, this rational function. So the first thing I'm going to do, if I ever see a rational function, I'm going to factor it. So I see the top will factor as difference of squares, x minus 1, x plus 1. And the bottom factors two numbers that multiply to negative 6, add to positive 5 will be positive 6 and negative 1. The first step should always be to factor. I'm going to write that here because that's something you should really remember when you're working on your test. So it says what value should be excluded from the domain? So all real numbers except for what numbers? Well, it's always going to be the numbers that when plugged into the bottom make 0. So these two factors on the bottom will give us our exclusions. So we can't have negative 6 because negative 6 plus 6 is 0, and we can't have 1. Now, as far as wholes, so obviously this x minus 1 cancels. And then in lowest terms, our function is just going to be x plus 1 over x plus 6. So whatever cancels, that's going to make my whole. So this 1 is going to make my whole. So my whole in my graph is going to be 1 comma something. Now, the y-coordinate of the whole, remember, we can just take the 1 and we can plug it into my lowest terms. So 1 plus 1 over 1 plus 6. So whatever you get for your x value, we're plugging into lowest terms. That'll give me 2 sevenths. So that'll give me the y value of my whole. Vertical asymptote is whatever doesn't cancel out. So in the lowest terms, we have this x plus 6 still in the bottom. So that's what's going to make my vertical asymptote. So whatever factor cancels is going to make your whole, and whatever factor doesn't cancel out is going to make your vertical asymptote. All right, let's look at C. C says list any horizontal or slant asymptotes. Well, that's all determined by the degree of the function. So if you look at the powers here, they are both x squared. And most of them will be things like this where you have the same power. So if you have the same power, it has a horizontal asymptote at y equals, you just divide the two leading terms, which would be x squared and x squared. You divide the highest powers that have the same degree. And so that gives you 1. Now y-intercept, remember, we just plug in 0 for x. So f of 0 is going to be 0 squared minus 1 over 0 squared plus 5 times 0 minus 6. So it's negative 1 over 6, which is 1/6. So my y-intercept is 0, 1/6. My x-intercept, recall, is whatever is going to make the top 0 in lowest terms. So if you look at that factor that's still on the top, it is x plus 1. So for my x-intercept, I'm going to take x plus 1 equal to 0, which is going to make it x equal to negative 1. So my x-intercept is going to be negative 1, 0. So with all this information, we can get a pretty good sketch of the graph. Now, of course, you can use Desmos or any graphing utility to sketch this, this function. But if I just sketch a little of the parts we made, we know it has a vertical asymptote at negative 6. There's a horizontal asymptote at 1. We know it has a point at 0, 1, 6 for the y-intercept and negative 1, 0 for the x-intercept. So you can almost envision what's happening. It's going to approach that asymptote. It's going to go through those points, approach it there. So probably the other part's got to go here to approach the asymptote there. Of course, you can always sketch this on Desmos. Make sure all these things work. So obviously I wouldn't do too many problems on this without using your graphing calculator. The only thing I might add to my graph is my hole is at 1, 2, 7, so I should probably put a hole there. So I should probably put an open circle there. But besides that, pretty good idea of what our graph looks like. Okay, slant asymptotes occur like in number 2 when you do the long division and you get a line. So a slant asymptote is typically going to be y equals mx plus b. We know a rational function has a horizontal asymptote if the degrees are equal. This one's 3, this one's 1, so it's definitely bigger on the top. So how we do this is we try to long divide to see if we can get a line. Now there are cases, and this is going to be one of those cases where you don't get a slant asymptote. And the way I can see this is if I take the x cubed divided by x, I get x squared. So the first term of my quotient is x squared. So I could continue the division, but I really don't need to because I know there's going to be no slant asymptote because it's not in the form if y equals mx plus b. Because slant asymptotes are always a line. They're y equals some slope times x plus an intercept. Since we already have x squared, I can stop. Now, if that was something x, I continue my long division, I'd finish it out, and I get some line, y equals mx plus b. But in this case, not necessary. All right, number 3 and 4 are talking about some equations. And there is a slight mistake in 4. This is supposed to be 3x, not 5x. So that was my mistake. It doesn't work out so nice if you keep it as 5x. So we'll change it to that. But for rational equations, remember what we're going to do. We're going to find the LCD of each one and then multiply every term by the LCD. Now, before we form the LCD, always a good idea to factor. But if I'm looking at number 3, there's really nothing to factor. It's just a 2 and a 5, so my LCD will be 10. So when I rewrite this, x minus 4 over 2, x plus 1 over 5, multiplied by 10 over 10, then what you'll see happen is this will reduce to 5 and this will reduce to 2. But the big thing that happens is I have a linear equation. 5 times x minus 4 equals 2 times x plus 1. I can distribute my two numbers, so 5x minus 20 equals 2x plus 2. I'll subtract 2x from both sides. I'll add 20 to both sides. So I'll get 3x equals 22. So x equals 22 over 3. Now, I should check if this is extraneous, but remember, to check if it's extraneous, you just plug it into the LCD. Well, the good news is there is no x to plug in for it, so this is not something we have to worry about. So our solution to this one is 22 over 3. So on this next one, I think it's going to be to our benefit to factor first before I find my LCD. So this one obviously doesn't factor, it's just x plus 3. This one doesn't factor, it's just x minus 6. But this is why we made that change to negative 3x, otherwise it does not factor. But now it will. We have x and x, two numbers that multiply to negative 18, add to negative 3, or negative 6 and positive 3. And so now if I look at my denominator, I'm looking for what's my LCD, what's in all the denominators. Well, it's quite simply x minus 6, x plus 3. So I'm just taking all the factors from all the denominators. So now I'm going to multiply that to all the numerators, whatever my LCD is. And then we'll see if some stuff cancels out. And it will. If we've done our work right, everything in the bottom should go away. So we have an x plus 3, the x minus 6 goes away, and here everything goes away. So where we're at is we have 2x times x minus 6 plus 3 times x plus 3 equals 27. So once I cancel out all the denominators, that's what's left. So obviously I have a couple distributions. So 2x squared minus 12x plus 3x plus 9, doing another distribution, equals 27. Now I can see that I'm going to have a quadratic because I have a square term. So I'll put the two x terms together. I have this plus 9, but then I'm going to move this 27 over, so I'm going to subtract 27. You could write it in a different step, but I know I'm going to move that 27 over. So my quadratic is going to be 2x squared minus 9x minus 18 equals 0. So now we have a quadratic. Now I'm pretty confident that if we do have a quadratic on your test, it will factor, and this one does factor as well. So however you factor, and we've gone over this a lot, there's lots of ways to factor. Everyone factors a little different, but all these ways are fine. But this should give us 2x plus 3, x minus 6, because there's our 12, negative 12, and there's our plus 3. So if I set those equal to 0, 2x plus 3 equal to 0, x minus 6 equal to 0. This one's simple, it'll give me 6. This one I subtract 3, and then I divide by 2. So my two solutions are negative 3/2 and 6. Probably. But don't forget, I have to plug these into the LCD and make sure it still works. So my LCD, if I plug in 6, I'm going to get 0 times something. So that's 0. So since this makes the LCD 0, I have to eliminate it as a solution. For the negative 3/2, if I plug it in, it's not going to make 0. I don't really care what it makes as long as it's not 0. So this is my only solution. Very common for you to do a problem, get two solutions, and have one be extraneous. They could both work, but a lot of times it does work out where one does not. All right, these last couple problems are on complex fractions. And just like the similar problems with the equations, we're going to find the LCDs. So if I look at all the denominators, I have x, 2x squared, x, and 3x. So when I'm forming my LCD, I know I have to have at least two x's because the one has x squared. And the numbers I see are 2 and 3, so I'm just going to put a 6. So 6x squared should have all these denominators included in it. So what I'll do is I'll go ahead and multiply all these by 6x squared. And then a bunch of stuff will cancel out. We have 1x cancel out here, we have the x squared cancels out here, and we have 6 divided by 2, which leaves me with a 3. So the top is just going to be 6x minus 3. Now on the bottom, I can cross out an x. I can cross out a 3 with the 6, which will leave 2. So that leaves 2x. You gotta be careful because there's a 2 and 1 x left. So I'm gonna go ahead and write that before I forget. And then I'm gonna cancel this x with one of those. So that gives me 2 times 6x, which is plus 12x. Now, I can see from this one, the bottom I can actually put together. Gives me 14x. Now as far as the top, I can factor out a 3. Leaves me with 2x minus 1. But remember, I can't simplify until it's factored. But if I look at this now, the 14 and the 3 don't reduce. I don't see a 2x minus 1. So this just should be my answer. All right, so for the last one, we'll do the same thing. Now, this one a little trickier because you notice I have that x squared minus 4 in the bottom. So what I'll do first is I'll go ahead and rewrite this in factored form. 1 over x plus 2 minus 3x over x minus 2 all over 5x times x minus 2x plus 2. So looking at all this, I think it's pretty clear that my LCD is just going to be those two factors because those are the only two things that end up in all of my denominators. So I'll multiply that by all the terms. So we'll go x minus 2x plus 2, x minus 2x plus 2, x minus 2x plus 2. And then a bunch of stuff will cancel. So on the top, I'll get x plus 2 minus 3x times x plus 2 all over just 5x. So if I distribute the top, I get x plus 2 minus 3x squared minus 6x all over 5x. So that'll be negative 3x squared minus 5x, because I got these two I could put together, plus 2 all over 5x. Now I can try to factor the top, but I know the bottom doesn't factor because it's just 5x, so that's going to be my answer. So you could try to factor the top. It may or may not factor, but I'm not even going to try it because I know it's not going to cancel with the bottom. So those are some examples that you'll see on your Chapter 3 test. Obviously, you can watch this review as many times as you want. And if you have questions, obviously reach out to me and we can talk about any of these you'd like.